Hello everyone, good to have you back again. So today we are going to introduce a new type of functions, a little more complicated than linear functions. They're not hard at all, but they're definitely a little more complicated than linear functions. We call them quadratic functions. Now let me, before I begin, let me clarify one misconception out there. Whenever you hear the word quad, you think of four, right? For example, quadrilaterals, like parallelograms or squares or diamonds or rectangles or rhombuses. We call them quadrilaterals because they have four sides. When it comes to the word quadratic, it actually refers to second degree. X is being squared, not something like this, not something like this, right? Not a fourth degree. It is just second degree. And of course, as you know, if you multiply a linear function by another linear function, you should get a quadratic function. The only conditions, this is called the standard form. The only condition is that the constant in front of x squared cannot be 0. Because if a is 0, that eliminates this term, and you'll end up with a linear function. Isn't that a linear piece? Like mx plus b, right? So that's your y-intercept, and that would be your slope. So we are not allowed to have, a cannot be 0. Okay? Now it's okay for b to be 0 or c to be 0. For instance, you could have quadratic functions that looks like this, or something that looks like that, or even just that, with no b, no c. So in here, c is 0. In here, b is 0. In here, b and c are both 0. That's okay. It's okay for b and c to be 0, but it's not okay for a to be 0, because if a is 0, then you end up with a linear function. So this is the standard form. Because it is a quadratic, you have to have, potentially, you'll have a quadratic piece, a linear piece, and a constant, and hence, three separate parameters, three parameters. These are just real values numbers, real value numbers, real values, okay? B can be anything, C can be anything, A can be anything except for 0, okay? Now, we need to know, just like when we discussed linear functions, we needed to know what are my two parameters, M and B. And we concluded that B is the y-intercept and M was the slope. Notice the y-intercept is not attached to x. In other words, when x is 0, y is b. So anytime you have a parameter that is not attached to x or x squared or x cubed, we know that's going to be the y-intercept, okay? So long we knew what the slope was and what the y-intercept was, I was able to know what my linear function is in this form, right? We had four forms. By the way, the good news, with quadratic functions, we only have two forms, maybe three, but not four, okay? So in our case, we need to know what do A and B and C stand for. So that's what I want to do next, okay? Because if you know what they mean and you are able to find them, we can do anything we want. Now, one practical example, and I'm sure you'll see in physics, of quadratic functions is free fall objects. So if you threw something off, fifth floor without pushing it down, you just free fall, it just lets go, it can be modeled by this function. I'm sure you've seen it maybe in physics. So let's call it h of t, which is the height of the function at time t. You probably have seen something like this, -½ gt squared plus v0t plus h0. That's your c, by the way. That's your b, and that is your a. Okay, now V0 is just initial velocity, h0 is initial height, and G, this letter G, is the gravitational force. I believe it's, excuse me, 32, it's a constant, 32 feet per second squared, or sometimes we say 9.8 meters per second squared. And sometimes you see 10 meters per second squared. It's just a constant. It's really not, it is a constant, but it depends on the location where you are in the world. In any case, for a free fall object, we know what G is, so that's why you see sometimes in books -16 or -5 t squared, because they're just replacing G by its value. And so long we give you the initial velocity, you know, what was the velocity when the object was let go, and from how far did you drop that object, we would know the quadratic function. So don't get scared of this type of functions. These are quadratic functions. A x squared plus b x plus c. T here is your x, right? And h of t is your y, or the heights at a time t. Okay, so that's a side note. But I just want you to know that quadratic functions are extremely important. So what are these parameters? How do we find them? And more important, what do they stand for? Okay, let's begin with A. A has a dual role. It plays one role with number 1, and it plays another role with number 3. Looking at the sign, SIGN, looking at the sign of A, you would already know whether or not your parabola is concave up, which means facing up, or concave down, means facing down. So if A is positive, the parabola will be concave up, so you would already know that fact. If A is negative, the parabola is concave down. One might ask, what if A is not positive and it's not negative, which means A is 0? Well, then you don't have quadratic function. You would only have a line, right? You would only have a line. And now we're back to what we've been doing for, I don't know, a month. So we're assuming A is not 0. So it's either positive or negative. If it's positive, it's concave up. And if negative, the parabola is concave down. The function is called quadratic function. Its graph is called a parabola. So don't say the parabola is quadratic. Don't say the function is concave up. The function is a function. Its graph is concave up / facing up, or concave down / facing down. So that's one thing that A does for us. So the moment I see my quadratic function, just by looking at this number in front of x squared, not x squared, it's the constant in front of x squared, it's called the leading coefficient. I'll write it down. A is the leading coefficient, very important, because B and C are also coefficients, but A is the leading because it is the constant in front of the variable that has the highest exponents. Okay, it's called the leading coefficient. So that's one thing A does. Now let's go to C, which is my number 2. Notice C is not attached to X. So I have a feeling C is going to be the y-intercept. Well, let's think about it. If you force X to be 0, when you force X to be 0, you're looking for the y-intercept. If X is 0, this piece goes away. That piece goes away. So my Y will be C. Therefore, 0, C is my y-intercept. Don't say C is the y-intercept. The y-intercept is the points. So you need to write 0, C, not just C, okay? So just by looking at this number, I already know my y-intercept. For example, let's say I have -3x squared plus 6x minus 9. I already know 2 facts. 1, because A is -3, which is negative, we know the parabola is facing down. That's a fact. Second fact, The y-intercept is -9, right? The function hits the y-axis at, so let's say it's like this, right? At 0, -9. You already know those two facts, okay? The third thing is, so we know what C stands for, and C only plays this role. Now let's go to the third piece. The third piece is going to reveal something about B, but it will also reveal something about A. And this is probably the most important point. It is a point, okay? It's called the vertex. The vertex is the highest point or the lowest point of my parabola. Okay, so this is called the maximum, and this is called the minimum, right? A minimum point, a maximum point. It is extreme. This point is more important than all the other points. These are the most important points. So this point 3, this third idea here, is addressing the idea of vertex, which is the highest points or the lowest points based on whether or not my parabola is facing up or facing down. If it is facing up, my vertex will be a minimum, isn't it? If A is negative and the parabola is concave down, then my vertex will be a maximum. And how do you find a maximum or the minimum? It's this point. The x coordinate of the vertex is -b over 2a. And of course, the y value is just plug in this value to get the value, right? So for example, when I plugged in 0, I get C. So you could call this point 0 f of 0. Isn't that true? So that's gave me 0, C. It's just the image of 0 is f of 0, which is C. The image of -b over 2a is f of -b over 2a. This is f of 0. Make sense? Just the image, okay? So don't get scared of these points, okay? Notice A shows up again. B by itself, by the way, doesn't do much. B needs A to get the vertex. And A by itself tells you the concavity only. But in coordination with B, it'll tell you the vertex. So these two guys gang up on the vertex. This only tells you the concavity, and this tells you the y-intercept. But both of these together, A and B together, give you the vertex. Okay? So let's work out an example. So here is an example. I just threw a function, f of x or y equals x squared minus 6x plus 8. What I would like to do, I would like to address these 3 points because I want to graph it. Okay? And that's all we're going to do today. So the first thing I always do is write down the values of A, B, and C. A is not x squared, okay? A is 1. There is a 1 sitting here. Don't say nothing. Nothing means 1, right? Because you are multiplying, so nothing in quotation mark means 1. So A is 1, not 0, okay? B is -6. Don't say 6. There is a negative sign here. So it's -6. Let me highlight the negative sign. Okay? And then C is 8. So first step, is the parabola concave up or down? Well, we know A is 1, which is positive. Therefore, the parabola is concave up. I already know how the parabola is facing just by looking at 1 in red. Okay? The y-intercept, I refer back to C. Now C is 8, so my y-intercept is not 8. It's 0, 8. It's a point. Okay? Then the vertex. Now I'm going to go back here to explain to you how do you do it. Well, let's find this guy first. And once I find this guy, I plug it in to get the image. Okay, so let's find -b over 2a. -b is negative or minus -6. Minus, this minus is that minus. And b happens to be -6. So there is a double negation. Minus -6 over 2 times a. A is 1. So that's 6 over 2, which is 3. So I already know that the vertex, the x coordinate of the vertex is 3. Now let's find f of 3, right? The image, this guy. All we have to do is plug in 3 in here. So 1 times 3 squared I put 3 in parentheses. Every time I call x, I put it in parentheses. Minus 6 times 3 plus 8. That's 9. That's negative 18. 9 minus 18 is negative 9, and negative 9 plus 8 is negative 1. So my vertex is 3 comma negative 1. Okay? So how do you graph it? It's literally a joke because you have all the ingredients. First, we know the parabola is facing up. So I just drew, don't look at the axes yet, okay? I just drew a parabola facing up. Okay? Then I drew my y axis a little to the left, not to the right. If I drew it here, the y-intercept will be very low. So I drew it here so that this looks like a 0,8. Why? Because that's what I got. Okay, so I drew a parabola. I drew my axis to locate my y-intercept. Then I went to my third point, which is the vertex, 3, negative 1. 3, negative 1. Now, the units on the x-axis does not have to be the unit on the y-axis. In other words, you might say, well, if this is 8, how could this be 3? Well, I chose 1 unit on the x-axis to be this much. 1, 2, 3. And I choose 1 on the y-axis to be maybe this much. 1, 2, 3, 4, 5, 6, 7, 8. Okay? The units, the vertical unit does not have to be the same thing as the horizontal units. This is 1 on the x-axis, and this is 1 on the right axis. I have the right to choose different units, okay? Because I want to have a nice graph. So now you might correctly say, well, let's just stick with the y-axis. If this is 8, this is about 4, this is about 2, so 1 should be just this much. Why did you go down too much? I would agree with you. I should move it up a little bit, shouldn't I? So I could maybe put negative 1 here correctly. Okay, I would agree with you. You have to be consistent within the same axis. Okay, I label my y-axis, I label my x-axis, I have my y-intercept, I have my vertex, which is my lowest points. If I have my lowest points and I have my y-intercept, I already know half the graph. The question becomes, how do you do this piece? And that's why I did this in green, to show you that this is completely new. Because according to this information, I can only sketch this piece, right? I know my lowest points. I know my y-intercept. And I know it's a parabola. It's not a line, okay? So don't draw a line. It's a parabola. So I know this half. How do I get the other half? Well, we can exploit symmetry. Parabolas are symmetric with respect to this axis. This blue line here, I'll give you its name later, is like a mirror, right? So whatever happens on this side should happen on this side, which means if you are standing right there, you the students, and this is a mirror, what would be your image, right? Because it's easy to find the image, and then I can connect again the vertex to this new image and do the other half. It's very easy. First of all, they have to have the same y value, same heights. The y value is the height. If this is 8, this has to be 8, right? So if you're standing right there, this is your eye, then your eye should be here as well. So we know the y value has to be the same. So we know 8 has to be duplicated. The question is, how did I get 6? Well, think about this. The x value of this point is 0, the x value. And the x value of your vertex is 3. In other words, this is 3. Going from 0 to 3. Because 0, the x value of this point is 0. The x value of the vertex is 3. So that means this distance has to be 3. Has to be 3. So I just duplicate it again. I add another 3, right? So if you are at 3, I'm only looking at the x values, not the y, okay? Just the x values. If I'm at 3 and I add another 3, I should end up with 6. So I know this point is 6, 8, and now I can connect the second part of my parabola, and I'm done. That's all I need. I need the y-intercept, the image in green, and the vertex, and that's plenty. I don't even need to know the x-intercepts. We will discuss that later, but I don't even need to know them, right? And that would end the story. Now, it is possible that you add 3 to 3 and write 7. You could make a mistake, right? But you can easily test whether or not this point satisfies the equation. Isn't it on the parabola? If it is on the parabola, it means it has to fulfill this equation. Well, let's plug in 6 here. Will I get an 8? Let's see. 6 squared is 36. And 6 times 6 is 36. So 36 minus 36 is 0. And 0 plus 8 is 8. I guarantee you if you plug in 0, you should get 8. I guarantee you if you plug in 3, you should get -1. We did it here, right? Because these 3 points are on the parabola. That means they need to satisfy the quadratic function. So this is one nice way to test whether or not you got the right points, okay? And that should end this video. Take care.